Finding a mystery number over here. This, at the end of the day, we realize we have to use this information to link together some kind of algebra, some kind of equation involving this missing letter over here. And we realize whenever we're doing normal distributions, it doesn't change the fact that we always start off with what? X is part of a normal distribution. You know, we always outline the problem. This is the habit we need to have. 1 over 4 mu to power 2. As in, no matter what, if you're dealing with normal distribution questions for AS, you always just write down first off, it belongs to normal distribution, and write down the mean and the variance. This is how you set up the problem over here. Next step, if you want to find what this is, it's clear that this is the information you use to work out what this is, isn't it? Are we all clear? Like, you have undefined numbers over here, which you know go towards a normal distribution to be set up like this, as in this is always the first step for normal distribution, and we're trying to use this information to somehow get an equation involving this missing letter over here. And this is where we'd realize this, it doesn't change, like, it's the same way we do normal distribution questions. We always draw graphs, don't we? We always end up just drawing like 2 graphs to illustrate that relationship, because graphs will always make it more clear rather than trying to figure out off the top of your head what's going on. As in, we have X, we have Z. This is very easy to do because we know the mean over there is just mu, goes there, bam, spot in the middle. 20 over there, 0.04. Make sure you know the basics over here. If it's bigger than 20 and it's 0.04 probability, isn't that you mean it's 4%? Only 4% of the entire graph is more than 20, that's what it's saying. So where do you think 20 is going to be? It's not going to be on the left, is it? It's very, very much going to be on the right over here. Because that's how you're going to get 4%. See how that works? So we're not confused about why 20 is on the right. Why we're trying to draw the graph? Remember, because if you're doing normal distribution questions, you always draw 2 graphs. The graphs will make it more clear. Easiest way to work from it. 20 over here, which we know corresponds to the Z graph over here, becomes 20 minus the mean divided by standard deviation. Standard deviation is, they give it to us, 1 over 4 mu. 1 over 4 mu, just like that. If you are so inclined, you can also think about it as 0.25, right? If you don't like fractions over there, you can just make this 0.25. Me personally, I don't mind. But why not? Let's make it 0.25 mu, just like that. And now, we know this is the Z number, isn't it? This is what they're expecting us to do with information. They're expecting us to know, oh shit, this is 4%. If this is 4%, doesn't that mean to the left of it is 96%? Why do we immediately think about to the left? Why do we immediately think to the left of it is 0.96? 96%? 0.96? Because whenever we're dealing with what? These types of graphs, isn't it? Normal distribution, remember? This entire table that we need to use. Remember normal distribution questions? We use this MM19 table on page 10. We only care about what? We care about areas to the left. This table only works for areas to the left. It's telling you the areas to the left of a certain number you look up on the Z graph over there. So that being said, we realize, don't we just need to look up the number? Finding the number that gives us 0.96. So isn't that reverse finding? We clear? We're trying to find what number over here that we can look up to get 0.96 area. So 20 minus mu divided by this. So this is just an algebra expression. If we make this equal to an actual number, we're guaranteed to solve what this missing letter is. So we go ahead and do that using the graph. Now the graph over here, remember, if you look on the bottom of MF19, page 10, bottom of MF19, page 10, 0.96 looks like a relatively clean number, isn't it? As in, do you remember this context over here? If you were to look up the, so bear with me. Does this ring a bell? If you have page 10 over here. Does 0.96 perfectly have something over there? Yes or no? Let's check. Oh no, it doesn't. So you'd have to reverse look up 0.96 indeed. Back to the question. Yeah, we found this is the Z number that if you were to look up would give you 0.96. So we just find what number over here gives us 0.96. We're not going from outside to inwards, are we? We're going from inwards to outwards because we're trying to find what number on the outside gives us an area of 0.96 on the inside. Is that clear? So now we go ahead and look up where do we get 0.96. Remember the way we go about doing this? What's the closest number to 0.96 without being over 0.96? Oh shit, it's this one. 0.9599. 1.75. That's where we get 1.75. How do we get 0.96? We need a 1 over there, which corresponds to 1 over there, and that's how we write 1.751. It's very basic stuff, okay? Make sure you know this. And that's how we got 1.751. That's how we got 1.751. And then you can see where this is going now. 20 minus mu, this is basic algebra. 1.751 times 0.25. Calculator, 1.751 times 0.25, which is 0.43775 mu. Move that to the side. -1 minus the right hand side number gives you -1.43775. Calculator is doing all this. 20 that side, -20. So mu is just equal to -20 divided by this number. So you press -20 divided by answer on your calculator to get 13.9106. So mu is going to be, we found over here is 13.9106 for mu. So we round that to freest F. Remember, non-exact numbers we round to freest F. The calculator number we found is a non-exact number, so 13.9 is going to be the mu. Finding the probability between this and this is a normal distribution question. Of course it is. Same principle, isn't it? X, squiggly line. Because we have these actual numbers now, do we need to write mu in this anymore, or is common sense tell you just going to be... We use 4 decimal places when we put in the parameters over here. We only put 3 decimal places, 3 SF, excuse me, for part 1 to show a final answer, but when we're setting up the question, it's still going to be what? It's going to be like 4 decimal places to be more accurate. 0.25 multiplied by our answer before is 3.4777 squared. Because standard deviation squared, it needs to be variance over here, mean over here. So very easy, we just do 10. You know what I mean? Like step 1 is the same always, isn't it? If we're doing normal distribution question, we set up what defines it, right? The mean and the variance. Next step, we draw 2 graphs. See how easy this is? As in, it's always applicable. If it's always applicable, of course, it's going to be a lot easier because you're guaranteed for it to work. 10 and 20 like this. So we put 10 and 20 like that. And then in the middle over there is 13.19106. And this is going to be 0. 20 minus 13.9106 divided by 3 point, because standard deviation is 3.4777. 10 minus 13.9106 divided by 3.4777. And what do these two numbers give you? See how this works? We're trying to find the area here, which gives us the probability here, which is what they're asking us for. So we just go ahead and do that. 20 minus 13.9106 divided by 3.4777. And that's where we get this number over here is 1.751. This number over here, 10 minus 13.9106 divided by 3.4777 is going to be negative 1.124. So all that's left to do is what? Find the area to the left of 1.751. See how that works? Because this is what we have, isn't it? 1.751 over here, negative 1.124. If we can find the area to the left of this minus the area to the left of that, we have the area we're looking for in the middle over there. That's the basis. So we go ahead and find that. Find the area to the left of 1.751 first. How easy is that? 1.751. Except what? Does that look really familiar to what we did before? Are we really even going to look this up on the table over here, or is there an even quicker way? Look at this. More than 20 is 0.04. See how this works? They already told us this is 0.04. To the left of 20, did we even need to look that up? Or to realize that's just going to be 0.96, isn't it? This number already to the left of is 0.96. We're not confused about that, are we? We already found out that to the left of 20 is 0.96. So we just need to look up the area to the left of this number. Area to the left of negative 1.124. Negative 1. Do you see how graphs? Do you see how many sort of graphs I'm showing over here to illustrate this? Because graphs make it so obvious, isn't it? It makes it so intuitive. This is the area we need to find. We can't look up negative. Look at this. Can you look up a negative number over here? You cannot. You recognize what? If you were to find what we need over here, negative 1.124, we need to instead find the area to the right of positive 1.124. So we look up positive 1.124 to find the area to the left of that, and do 1 minus to find the area to the right, which gives us the same as the area to the left of negative 1.124, which is what we're trying to find over here, right? We're trying to find this area. So we look up 1.124 over here. Where is 1.124? 1.12. So it's 0.8665 plus a 4 at the end, which is 0.8669. Area to the left of 1.124. So therefore, area to the right is just, you type in your calculator, 1 minus 0.8669 to get 0.1331. 0.1331. 0.1331. And we know the area to the left of this is 0.96, to the left of this is 0.1331, so therefore the area we're trying to find is just going to be 0.96 minus 0.1331, which is 0.8269. Which after free SF is just 0.827. So far so good? "250 independent observations of X are taken. At least 200 independent observations. a set number of observations, a set number of things, at least 250. Does this sound like binomial, yes or no? Okay, no confusions. This is one of those binomial to normal approximations, isn't it? N is equal to 250, they're telling us. What's the probability then? Less than 20. Oh, if the more than 20 is 0.04, isn't less than 20 going to be 0.96? You see where we're going with this? Oh shit, it's binomial basically. And you realize step 1, binomial, you write down what it belongs to, binomial. Next step, you know it has to be binomial to normal approximation, which is, what's the mean and the variance? If you're going from binomial to normal, you remember from MF19, look on page 8 of MF19, formula sheet. Is there literally 2 formulas right next to the binomial one that tells you number times probability times Q, as in 250 times 0.96 times 0.04, gives you the mean and the variance for a normal distribution, if you were to go from binomial to normal. Basics over here, right? Assume you do know the basics. So you go ahead and write that in. Because you know for a fact you have to do normal approximation over here. 250 times 0.96, which gives you 240, comma, multiply that by 0.04, NPQ, right? N times P times 1 minus P, written on the formula sheet over there, 9.6. So you've got the mean and the variance now for normal. And next step is just to at least 235. Remember, continuity correction always has to happen for these types of questions, 235. Best way to do this, continuity correction, how do you do that? You just draw 3 bars, at least 235. Oh, shit means like this, isn't it? Can be equal to. As it includes 35, at least can include 235. So that's how you realize it's going to be actually 234.5 onwards. Next step, graph. See how this works? See how easy this is? Every single time you do 2 graphs. Because the work kind of just does itself over here if you have 2 graphs, because it becomes so obvious. If this is 240 in the middle over there, right? Just intuition, you know, middle, the mean goes in the middle. More than 234.5 is just, here's 234.5. Oh, so we're just looking for this area. And this corresponds to 234.5 minus 240 divided by the square roots of 9.6. So don't make the mistake. Minus 240 divided by the square roots, because this is the variance. Square root of variance gives you a standard deviation. And that's where you get negative 1.775 over here. How do you find the area to the right of this? Can you just look this up on the graph? No, you cannot. You can only look up area to the left of 1.775, which you realize, oh shit, isn't that the same? See what they're testing you on over here? Area to the left of 1.775 is the same as area to the right. So you just look up 1.775. Where is 1.775? 1.77 over here, 5 over here. So 0.9616 and a 4 over there, 0.9620. So answer over here for part 3, 0.96. Was it 2? 20, yeah. Okay. Also, have a think about the common sense of this question. That's a pretty high probability. That's pretty much 100%. 96.2 is almost, here, 90.62% is almost 100. It's almost guaranteed. And when we think about this, if it's 250 things that are possible, we're going to find at least 235, so be pretty much at least most of them, right? Are less than 20. Well, what's the probability that it's going to be less than 20 in general? It's 0.96 probability. So of course this makes sense, doesn't it? It's that high of a probability to be below 20, which is 96%. So the probability that majority of them are going to be less than 20, of course it's pretty close to 100% also. Just for some context here.